This tutorial walks through the process of creating a simple blockchain with the goal to show the user how a blockchain works behind the scenes. Although the process of creating a blockchain is very technical, this example is basic and meant for even those without a technical background. This tutorial then goes on to do a simple example to show the security benefits of a blockchain. So without further ado, the first thing that we need to do is create a block. And in this case, the block is going to be comprised of an index, a timestamp, data, something called a previous hash, and then something called a hash. The index in this case is just the order of the block. The timestamp is going to give the time the block was created. The data is going to be whatever data we decide to put in this block. Then the hash function, which I can also define down here, is going to take every other piece of information in the block and use it to create a unique identifier. The previous hash is then going to be the hash of the block that just came before the current block. So with that information, next we're going to look at the blockchain. So when we create this blockchain, the first thing that we need to do is create the genesis block. Now, when we created the genesis block, the first instinct might be, wait, we already created the block, why do we need to create another one? Well, this is because this will be used to create every other block in the blockchain, but the genesis block represents the first block, and we need to create this one manually. So to create the genesis block, I put the index as 0, the timestamp as the first day of the year. The data is just going to say genesis block, and then the previous hash is 0. Next, we're going to create a function called getLatestBlock, and what this function is going to do is simply retrieve the latest block in the blockchain. Next, we're going to create a function called addBlock, which will enable us to add a block to the blockchain. And it does this by taking the previous hash and setting it equal to the hash of the latest block in the blockchain. And then it generates a new hash for the current block, and then it pushes it to the blockchain. Next, we create a function called isChainValid. And what this is going to do is check to see if any block that we try and add to the blockchain is valid. And it does this by looking at the hashes. So if the current block's hash does not equal the current block's hash, then return false. Similarly, it also looks at the previous block's hash, and if those two don't equal each other, then it also returns false. And for everything else, it returns true. Now we're ready to initialize the blockchain, which I've done here, calling it MSBA coin. And I've also added 2 blocks to the MSBA coin blockchain. The first is going to have an index of 1. This will be the timestamp, and it will have the data of amount 7. And then the second one is going to have an index of 2. This is the timestamp, and with the amount 10. Now, before we tamper with it, let's just check to make sure the blockchain looks okay. Looking at the output of this blockchain, it appears that everything is okay, because if we look at the hash of the genesis block, we can see that it matches the hash of the block that precedes it. Following the hash of this block matches the previous hash of the next block. So for now, everything seems like it's fine. Next, we're going to try and tamper with the blockchain. Firstly, we're going to try and change the amount in the first block to say 100. Say we're having a transaction, I'm going to try and take 100 instead of 7 from you. Now, if you remember, changing the data in a blockchain is also going to change its hash. So we're also going to try and recalculate the hash for this block and see if we can still successfully get away with tampering. Then we're going to run this line, which will run the is the chain valid. We see that even though we recalculated the hash, the block still comes up as false, and this is because the previous hash will still not match. In closing, blockchain is meant to add blocks to it, but to never delete a block or to never change a block once it has been created. In real life, if you were to detect a new block that broke your chain, or if something is wrong with your chain, then you should have a mechanism that puts your block back in the correct state. But that's beyond the scope of this demonstration. This demonstration also lacks many features such as proof of work or peer-to-peer network to communicate with other miners, and it doesn't even check to see if there are enough funds to make the transaction. So there are many limitations to this demonstration, but this demonstration does effectively show how a blockchain works behind the scenes.